Results from study to estimate radiation doses and cancer risks resulting from exposure to radioactive fallout from the Trinity Nuclear Test. Stephen L. Simon, PhD, September 1st, 2020.
Hello, everyone. I'm Dr. Steve Simon, the principal investigator of the National Cancer Institute study to estimate radiation doses and cancer risks resulting from exposure to radioactive fallout from the Trinity Nuclear Test. Today, I will share a summary of our findings as presented in a collection of 6 scientific papers published today, September 1st, 2020, in the journal Health Physics. Digital copies of the papers have been shared with you, as well as a summary written for the community. All are also available on our website. This study involved a number of well-qualified experts, both at the NCI and external to the Institute, in subject areas including data collection and interviewing, dietary customs, radiation physics and dosimetry, epidemiology, statistics, and risk assessment. As a reminder, Trinity was the first nuclear test in history, conducted on July 16, 1945 in south central New Mexico. It was the culmination of the Manhattan Project. Using current tools, this study is the most detailed dose and risk assessment available for the residents of New Mexico as a consequence of the Trinity test. The primary goal of our study was to estimate the possible radiation doses received by New Mexico residents in 1945 and the number and types of excess cancers that may have arisen as a result of exposure to Trinity fallout. This work could not have been done without the cooperation and support of numerous local experts who include the following: historians and advocates in New Mexico, particularly members and leaders of the organization Honor Our Pueblo Existence, HOPE, the Tularosa Downwinders Consortium, and Las Mujeres Hablan, as well tribal and Pueblo leadership who agreed to participate in interviews and focus groups to inform the dietary models central to the scientific approach. And most importantly, elders from areas across New Mexico and at senior centers that opened their doors to the research team. This project was supported by the Intramural Research Program of the National Cancer Institute, with additional funding from the National Institute on Allergies and Infectious Diseases. We give special thanks to the Southwest Tribal IRB for their careful review and approval of the study protocol, as well as of final manuscripts for publication and the summary written for the community. The digital publications are being made available at no cost to any person or parties who would like to download them. Before I describe how the study was conducted and review the study results, I want to say that our study provides the most comprehensive evaluation of the doses and risks today. However, at the same time, we acknowledge the study's significant limitations. For example, the study cannot determine the dose for any individual because of the absence of information about their exposures. Instead, we provide estimated doses for representative persons in all counties and all ages and ethnicities. Moreover, we cannot determine the cause of cancer in any individual without information about their actual true dose, which is unknowable, but also about other factors related to cancer risk. The study was comprised of 4 strategies. First, literature review, input from knowledgeable experts and interest groups, and pilot testing of methods. Second, data collection. Third, dose estimation. And fourth, risk projection. Today, I will focus on the data collection, the dose assessment, the risk projection, and on 2 additional questions the study addressed. I will now briefly talk about the methods and goals of the data collection. Data collection used well-accepted interviewing and focus group methods. The collection abided by all regulations and protocols specified by the NIH Institutional Review Board, the Southwest Tribal Institutional Review Board, the U.S. Office of Management and Budget, and the councils of the Native American tribes that participated. Following discussion with local experts and a pilot study to determine how to best and effectively collect data from elderly New Mexico residents, we initiated a full study to collect data on diet, that is, the types and amounts of foods consumed and where those foods were obtained from, as well on housing construction type, as it is important to understand home construction since it determines the shielding from fallout radiation, and finally on time spent outdoors in summer months. Data were collected through 13 focus groups and 11 individual interviews with elders over the age of 70 years who lived in New Mexico at the time of Trinity. Confidentiality with respect to the identity of persons and groups, including Native American tribes participating in the data collection, was fundamental to the design of the study and has been maintained. I will now talk briefly about dose estimation. The NCI investigators used published mathematical exposure assessment models, or made modifications to published models as necessary, in order to estimate the likely exposures, that is, the radiation doses, from external and internal radiation. The dose estimates accounted for exposures from 13 types of foods and drinking water. It also accounted for the type of home construction, time spent outdoors in summer months, and breastfeeding habits. The data to describe these habits were collected, as I described, from New Mexico residents alive at the time of Trinity. In order to determine fallout contamination across the state, the study relied primarily on the map of fallout deposition published in 1987 by the Weather Service Nuclear Support Office in Las Vegas, Nevada. That map was based on a synthesis of exposure rate measurements taken by Manhattan Project scientists in the days immediately after the detonation. The pattern is loosely referred to as the Quinn pattern, referring to the lead meteorologist, Dr. Virgil Quinn, who derived it. For the northernmost part of the state, that was outside of the region where measurements were made and outside the Quinn fallout pattern, we used the findings from fallout contamination calculations made by the Lawrence Livermore National Laboratory. Best estimates of radiation dose were made in this study for 5 organs, those being thyroid, red bone marrow, stomach, colon, and lung, those organs at greatest cancer risk from exposure to fallout. The estimates were made in 4 ethnic groups, those being whites, Hispanics, Native Americans, and African Americans, and in 7 age groups, covering the ages from in utero to adulthood. I would now like to share a few slides with you to better illustrate the dose assessment process and a summary of dose findings. This first slide is a map of the state of New Mexico, showing the counties as they existed in 1945, similar to a map of the state today, except that present-day maps would also show Los Alamos County, which was created later, and both Valencia and Cibola, whereas at the time there was only Valencia County. The star represents the approximate location of the Trinity detonation. This next slide depicts the approximate central locations of the 721 voting precincts in 1945, covering the entire state, and derived from an historical map provided by the Library of Congress. We estimated the fallout exposure rates from the Quinn fallout map at all 720 locations to assist the dose reconstruction. The next slide is basically the same map, but it also shows the locations of the 8 population centers in New Mexico in 1945, with population centers defined as those towns and cities with more than 10,000 persons each. The next slide is a composite of the earlier slides, but also shows the exposure rate contours from the published fallout maps. Note that the fallout does not end at the outermost contour, but it simply reaches a very low value across the rest of the state. In this next slide, we superimpose the results of our external dose calculations, which are the doses accumulated over the year following detonation, and that use the data from the fallout contour map. The red areas are those where the greatest external dose would have been received. Areas without any color are those with much lower doses, approaching annual doses from naturally occurring background radiation. The final slide in this section shows the 5 counties that received the highest doses, those being Socorro, Lincoln, Torrance, Guadalupe, and San Miguel. Although the study provides estimate of dose using the best available scientific tools, our ability to precisely reconstruct doses from 75 years ago is limited, and therefore these estimated doses are subject to considerable uncertainty. That uncertainty is described in the scientific manuscripts by uncertainty intervals, where we characterize the range of possible doses in which the true dose likely lies. As shown on this map, we concluded that only in small geographic areas immediately to the northeast of the detonation site, along the predominant wind direction, only those areas experience exposures substantially higher than annual doses from naturally occurring background radiation. Of course, the pattern and areas of high internal doses would closely track this map of external dose. I will now briefly describe the methods and findings from the population risk projection. Because New Mexico did not start collecting data on cancers or tracking cancer cases for more than 20 years after the Trinity test, today's designs for analytic or follow-up epidemiologic studies could not be implemented because that approach would typically first assess the reported numbers of cancers that have occurred over the years after the exposure. Therefore, we set out to estimate the excess number of cancers that may have already occurred. Excess meaning those in addition to what would be expected in the absence of Trinity. We also projected the excess number of cancers that might occur in the future, again based upon estimated radiation doses, the number of persons exposed, but in this case also upon the estimated number still living in each successive year. I would like to graphically show the steps and the input data needed for the risk projection. As you can see, all of the essential elements come together here for the purposes of the risk projection. The collected diet and lifestyle data, as well as the fallout deposition information, are used in mathematical models for the dose reconstruction. In turn, the estimated doses for the ethnic groups and the population age distributions, along with the baseline cancer rates, are used in the risk projection to project, that is, to estimate, the number of excess cancers caused by Trinity for each organ, age, ethnic group, and across the entire state. The U.S. Census reported about 580,000 persons residing in New Mexico at the time of Trinity and could have been partially exposed. For the risk projection, it was necessary to use the baseline rates to estimate the number of cases that would eventually occur amongst the population alive in 1945. Here, I want to reiterate the definitions of baseline and excess cases. Baseline cases, that meaning the number of cancers expected over the lifetime of the 1945 New Mexico population if Trinity had never taken place. The baseline cannot be known with certainty. Cancer registry began, as I mentioned, 20 plus years after Trinity. Baseline rates, that is, typical cancer rates in New Mexico before the Trinity test for the different ethnic groups, were estimated from the most relevant data that could be identified in the NCI's nationwide Cancer Surveillance and Registry program known as SEER or SEER. The excess cancer cases, that is, the number of additional cancers above the baseline number that are estimated to have been caused by Trinity amongst the exposed population. The excess number cannot be known with certainty, but can be crudely estimated by risk projection methods. Accepted statistical models were used for risk projection, and estimates of the number of excess cancers were accompanied by detailed calculations to estimate the uncertainty intervals, that is, the range in which the true risk is expected to lie. The projected number of excess cancers was derived for the 5 previously noted organs, plus all other solid cancers combined, for populations in all counties, of all ethnicities, and all ages. Here I present the uncertainty interval on the projected number of possible cancers resulting from exposure to fallout from the Trinity test. We estimated that the number to be greater than 0 and less than about 1,000 cases across all cancer types over the 80 years following the test, that is, until 2034. The excess number of cases of 1,000 can be compared with the estimated baseline of 183,000 cancers amongst the cohort alive in 1945. Among the types of cancers assessed, the fraction of cancer cases attributable to radiation exposure was greatest for thyroid cancer. That is because the thyroid gland is the primary organ that concentrates radioactive byproducts, in this case, radioactive iodine, typically I-131. I will now discuss our methods and findings on the likelihood of adverse pregnancy outcomes and genetic diseases, that is, intergenerational effects from exposure to Trinity Fallout. In response to interest from stakeholders, the NCI study team proposed to an outside expert to conduct an analysis of intergenerational effects based on the published scientific literature. This paper examines the evidence for adverse pregnancy outcomes and the evidence for the induction of genetic diseases, that is, inherited disease, among second or later generations. The data examined included studies of workers at Los Alamos Laboratory, the uranium mill in Grants, New Mexico, atomic bomb survivors in Japan, military veterans exposed to radiation, and the offspring of childhood, adolescent, and young adult cancer survivors who had been treated with radiation, and finally, even scientists who participated in the Trinity development and the Trinity test. The overarching conclusion was there was no good evidence to suggest transgenerational effects could have occurred from Trinity. Two reasons for an absence of evidence from Trinity were: in all large comprehensive studies of exposed population, no genetic effects have been demonstrated in children of exposed parents. Furthermore, the doses from Trinity are for the most part smaller than in other study populations where no transgenerational effects have been observed. These conclusions are consistent with the published scientific literature that suggests that intergenerational effects either do not occur or at most occur at such a low frequency that they cannot be conclusively observed. I will now briefly discuss our methods and findings to account for unfissioned plutonium. This paper analyzes previously published measurement data on unfissioned plutonium from Trinity in soil in New Mexico. Because Trinity was the first nuclear device and there was little experience in optimizing its design, it was inefficient in transforming the plutonium fuel into a nuclear explosion by what is called nuclear fission, meaning the splitting of the atoms. Of the 6 kilograms of plutonium that fueled the Trinity device, only about 15% underwent fission. The rest was vaporized in the heat of the explosion, and upon cooling of the debris cloud, the plutonium cooled and formed small particles that fell to the ground. Because of the high density of plutonium particles, most of the particles fell out of the atmosphere relatively close to the test site. About 80% of the plutonium was estimated to have been deposited in New Mexico, with most in the close-in Chupadera Mesa area, 30 to 100 kilometers downwind, that is, 16 to 60 miles downwind. To determine the whereabouts of the deposited plutonium, the investigators collected, analyzed, and summarized data on dozens of measurements of plutonium in soil that had been reported by various organizations over the decades. From published data and our analysis, we derived a map of the likely deposited plutonium in soil. That map closely parallels the shape and characteristics of the fallout map we developed for exposure from fallout, but with somewhat greater concentration at close distances. The greatest hazards would have been from inhaling particles at the time of deposition, that is in 1945, and to a much less degree inhalation of resuspended and contaminated dust over successive years. We found that the concentration of plutonium at the time of deposition in the top 1 centimeter of soil, that is, in the soil most available to exposed persons, would have been less than the U.S. EPA's action level published in 1977. The action level is the level that the agency would have required remediation to protect human health, even given conservative assumptions about exposure. Today, the concentration in the surface soil is estimated to be about 30% of the concentration in the surface soil at the time of deposition, due to the continual downward movement of the plutonium into the deeper levels of the soil. This concludes my presentation to summarize our study. Much more information and detail on the findings are available in the published papers, linked from our website, which is provided here. I'd like to again thank you for your attention during this presentation, and to those that participated in the study in any way, I want to express the sincere appreciation of the study investigators. Thank you all very much.